Here we have a substrate molecule that interacts with the active site of an enzyme. Given there is nothing to prohibit the substrate molecule from interacting with the enzyme, the substrate molecule can easily form the enzyme-substrate complex. Following this formation, the substrate molecule undergoes a chemical reaction where it is converted into its new form. Here, a molecule similar to the substrate, when unable to be acted on by the enzyme, competes with the substrate molecule for the active site. This molecule is called the inhibitor. This inhibitor prevents the substrate molecule from interacting with the enzyme in order to form their product from the reaction.
Here, the non-competitive inhibitors are usually structurally unrelated to the substrate, and therefore bind to an allosteric site on the enzyme, or the non-active site on the enzyme. Allosteric regulation is the regulation of an enzyme by binding an effector molecule at a site other than the enzyme's active site. Inhibition occurs when the end of a product of a reaction interferes with the enzyme that helped produce it. The inhibitor does this by binding to a second active binding site that's different from the one attached to the initial reactant. The enzyme then changes its shape and can't. Enzymes work consistently until they are dissolved or become denatured. Enzyme denaturing occurs when temperatures or conditions of an environment are not optimal. When enzymes denature, they are no longer active and therefore cannot function.